Hello, it's Duncan. My exploration of JetBrains' HTTP library concludes today with a comparison of the same functionality implemented with Ktor and http4k. That's it really. Please watch it to the end and let me know in the comments if you agree with my conclusions.
Last week we took the tests that we wrote for the Ktor app, that is these customer root tests, and re-implemented them for http4k into this customer root http4k tests. We did quite a good job so that the differences between the tests are just in the imports, and there are no changes to the actual test logic here. But these things actually call different methods. So test application with is this thing in here, but it's something else when we're testing Ktor. And we adapted http4k's handlers to have the same sort of methods as we have in Ktor, like delete and get and post, etc. That was an interesting study in how we create a DSL in Kotlin. So if you haven't seen it, please go and watch it. But it wasn't really the point. The point was to be able to use the same tests against http4k as we used against Ktor. And we left the http4k version ignored so that it doesn't run. But if we take that out and we'll run all the tests, see what we get. All of our http4k tests fail and our Ktor tests pass. And the reason for that is this not implemented that comes about when we try and build an http4k handler. So it's not surprising. So our mission is to implement this http4k handler here to do the same as the Ktor root handler. Let's find that. Don't actually remember how to, but we'll have a look here. I hope we are lucky. It's quite simple. It's customer roots. So we'll open that and clear the decks. So this is a Ktor version of our customer routing. You can see we create a root on customer, and then we have different blocks for the different http4k verbs and a block for the verb with a path in it. What I propose to do is semi-cleanroom implement this by making the http4k tests work without reference to this, and then compare the http4k and Ktor code to see what we can learn. So we'll put this away and we'll just look at the customer root tests. Okay then, let's give ourselves a function, or at least pretend we have a function, and we'll call it roots for and in this case we're only interested in the customer storage, so let's pass that in. And let's create that somewhere. So this is going to be something that takes our mutable list of customers and returns an HTTP handler. And now I think I'm going to take that, move it out of here to the top level so we know it doesn't depend on the test, make it public, and then move it somewhere into our production code. So we will say we want to move roots for into com example, that's fine, but we want to put it in main. Let's see what happens when we do that. Add that to git. And now let's have a look. In our project we have roots for, bad name. Let's move that into roots. And we'll say that this wants to be not roots for, but http4k roots. Now, something went wrong there. Don't know what. An internal error. Let's try rebuild. Well, that seems to have got us back on track. So, let's take our roots over here and our tests here and look at making our test pass. Okay, what's the first one? Go up to the top and we have returns no customers found when there are no customers. So we start with an empty list of orders and we want to do a get on customer. So the first thing I'll do is I will run all of our tests and we fail where we expect. And now I'm just going to turn off line numbers so that we can see just a little bit more. Not much more to be honest, but let's say in here that we want to use the http4k roots function to compose some roots for us. And we'll import that. And now we have this little DSL which will allow us to bind /customer to match that, bind method get to match that get, that's good, to something else, bind get to request response. That's good. And so in here we would have to return a response, and for now we'll just return a response with status dot. we've got to import a bunch of things. So F2 bind, we can import. F2 to go and get, we need to import that one. And now in order to make it a bit shorter, let's static import that. There. Request, we need to pull in as well. Response, we need to pull in. And once again, we can shorten things like that. Okay, don't need to specify the request, and we'll drop that down onto a line so it looks like that. Now then, we can make this first test pass by just returning a body of no customers found. So we say body with a string of no customers found, and that will allow us to see whether or not we've wired up our routing correctly. So we'll run, and indeed we have one test passing. Brilliant. I think we have to question the sense of that result, given that if there are customers, we return a JSON array, asking our clients to not pass that as JSON, look for no customers found, and then only pass it as JSON if it hasn't found the literal string no customers found, is a bit of a stretch. But this is the spec, so we will implement it. Okay then, to express our annoyance a little bit, we'll add an if in here. So we say if customer storage is empty, then our response is going to be that, else, and we can put a to do in here. Run that. And that should throw an exception, I think, when we actually have some customers. Maybe this one. There we go. Okay then, how do we fill in this to do? We can see from this test here that if we have got some customers, then we want the JSON representation of the customers as an array. Now we know that Ktor is using Kotlin X serialization, so that our customer, for example, here is annotated with serializable, and that means that JSON mapping code will be generated. So we should be able to reuse that, and http4k has a mapping to Kotlin X serialization, and with the right import, all we have to say is that our JSON serialization is Kotlin X serialization. And that can be a private val. We're just bringing in a namespace effectively of JSON operations. And using that, we can say response OK. And hot news, as of the latest release, we can just say .json and pass in the object we want marshaled, which in this case is customer storage. Now that is an import. It's an extension function. Oh, it turns out I was wrong. In fact, we don't need to import JSON here. I'm assuming that we are importing JSON here from configurable Kotlin X serialization, whatever that is. Well, that looks quite useful, so let's see whether we can just get rid of that. There in fact is the import, so we can get rid of that. And you can see that we now have an extension function on response that knows how to use Kotlin X serialization to serialize plain old objects. Well, that might work. Let's give it a go. Let's have a look, and we now have two tests passing, returns no customers and returns all the customers. So it looks like our JSON is working. Splendid. Let's go on to the next one then. If we go and get customer ID, then we want an OK, and we want the customer as JSON in the body. Okay, how do we do that in http4k? Well, we can add in another route, and we can bind /customer/ and then a little special bit of syntax there. And IntelliJ is completing that rather cleverly, I think. That's good. So what do we want to do? We want to say response, OK. And we need to use the ID path parameter to find an item from our customer storage. And we do that with, well, goodness me, IntelliJ is on the ball there. We go to the request, we ask for a path parameter of ID, like that. Now we can say our customer is customer storage. Oh, this is getting creepy. And then finally we can say result.ok JSON with our customer. Now the type system is helping us because it's telling us that this customer is nullable because we might not be able to find it in the customer storage. So we have to deal with what to do with a nullable customer. Slightly interesting that we can't pass null as something to render in JSON, because I think you can render null in JSON, but that's okay. Let's just add ourselves a special case for now. We'll say if customer equals null, then we want a response not found. And I think that will be this test here. So this is status.notfound. We'll import that so that it's short enough. And The response here wants to be apparently no customer with ID, no such ID. So let's take that and put it into here as our body, which is going to be that thing, else that thing. I think there's half a chance. Let's run it. That's splendid. So it returns 400 with no ID we haven't put in. And I think that's about this request.path here. This ID is nullable, but if it is null here, we're just not finding a customer whose ID is null. That sort of can't happen. So I think maybe we should change this into a when, and then we'll handle the case of a null ID. We'll move the subject out of there. Doesn't seem to be a thing. Just take it out ourselves. So we'll say when the customer is null, and now we've got another case which is when the ID is null. And in that case, we want to be returning missing ID with bad request. So this is going to be bad request, and this is going to be capital MISSING ID. How are we doing? Interestingly, that doesn't pass. Let's see if we can work out why. I suspect the answer is that this request here, the one that is just /customer/ is binding to this route rather than this one. Don't know, but let's see whether swapping these two round fixes the issue. Bit of an edge case, but we'll try it out. No, still no joy. I think it may be time to break out the debugger. I'll put a breakpoint in here and a breakpoint in here and run just this one test in the debugger. And we have indeed bound to the plain old customer without a slash rather than getting a look at the ID at all. I think I may require a bit of help with that one. Okay then, a chat with the http4k support department revealed that whether or not we put a trailing slash on the end, if there's nothing after the trailing slash, we'll bind to this route here. So the solution to a problem, if we want the API that we have over on the left-hand side, is that we can check the path here, and if we do see the trailing slash, then we can respond with bad request. It's not brilliant, but it gets us running. I should say also that I have commented out the tests that don't pass so that I don't get confusion over what is and isn't working. Okay, let's push on. Let's try delete the customer by ID. So we'll re-enable that and run. And that will fail, and we're getting a 405, and 405 is a bad method because we haven't set up a handler for the delete that we're sending here. So let's do that. We'll go in here and we'll say on /customer/ID again, we will bind delete to a handler. Let's first of all return the right status code, which appears to be accepted. So here we can say respond with a response of accepted. See whether that gets us a bit further, and it does. So we expected a body of customer removed correctly. Let's add that into here. Push on. And now we're expecting the customers to be empty. So we have to find the customer by ID and then remove it. So we need to have that ID. That's this. So I think we should be able to get the ID, and then says customer storage dot remove if it dot ID equals ID. Does that get us passing? Splendid. What's next? Well, we can't find a customer to delete, then we should return a 404. Run. So we can say val worked is remove if that, and then we can say when worked is true, we want our accepted, else we expect a not found and a body of not found. So we are getting pretty close to that completion, aren't we? Let's ask it to do it again, and it seems that we have capital letters in there. Run that. Wonderful. And I think I just tidy this up a bit. Let's rename that to be deleted. And I'm just going to drop those down so we can see more of them. Still good. Returns 400 when no ID is given to delete. Reinstate the test. Run it to check it fails. It does. And now I think given that we're sending a delete, we may well bind to this one. Just going to find out by setting a breakpoint there and debugging that. And we don't hit it. What do we get? We get a 405. So that's method not allowed, and I suppose the problem is that we are only binding paths here with an ID in them. We say we want a 400 when that happens, which is bad request. So I suppose we're going to have to hand wire that a little bit. What we'll say is we'll take this thing, I guess, and add in a route for it with our newfound knowledge that is that if I bind delete on customer, then I probably always want to send a response with bad request. Do we have a body? No, we don't. So does that get that passing? It does. Good. Carrying on. Add the customer. See it fail. That's rather strange, isn't it? We're only running one test. Run them all. Now we're failing with the one. We're getting a 405, which again is method not allowed because we don't have a post. So let us bind customer to something that returns created, which is the thing that's required here. That will get us through these asserts, but we won't have added a customer. How then should we add a customer? Well, when we're returning a customer, we're able to populate the response with a JSON extension function. Where was that? It's here. So we could say response OK JSON. So it'd be nice if we could do the same thing. Let's go back here and we'd say that my val customer is request.json. And I suppose I probably need to tell it that I was looking for a customer for it to deserialize out of there. And of course we need to tell it that we have a request, or at least give a name to one we have. Now then, this request JSON does exist, but that's the one that writes, not one that reads. But you see here it's implemented with a body lens. So let's take that and come back here, and we'll say that val lens is a body auto of customer, and then we could use that lens to extract from our request. Now that's a customer, so we should be able to say customer storage, add that customer. Let's see how that goes. Oh, that's good, but it's still not as friendly as we thought it might be. However, I wonder whether we could write the functionality we're looking for ourselves. An inline fun of a reified T that is an extension on request and is called JSON. And that will take our body lens, something like that, and apply it to our request, which is this. But we can say we don't want just a customer, we want a T. And I think the T needs to be any. We can't extract null. If we do that, then the type of this thing is going to be a T. If we're very lucky, now we can say request.json, tell it we want to suck out a customer, and get rid of that. Is that working? Still yes, apparently. Good. So only one last commented out test, this one, and that is that we return a 415 when there's no customer to add. What's a 415? Looks over to Mozilla Developer Network, and it is unsupported media type. Okay, let's run. And we are failing. And what are we returning? We're throwing a lens failure. Unexpected start of object. We were looking for a curly bracket for JSON, but end of file, which is an empty string. This one I think might be a bit complicated. Ordinarily, when we're using lenses in http4k, the lenses will throw if there's something wrong, and we just saw that. And then we report problems by adding in a filter. So up here we'd say server filters, catch lens failure. Don't know what customer storage is doing there. And then the rest of our handlers. And we have to go down the end here and put in that bracket. If we run that now, then instead of catching an exception, we are returning a status code of 400, which is bad request. Now I think maybe bad request is a better status code than 415 in this case. I mean, we don't really know what the media type is if it's an empty string. Or maybe we do, we know it's not JSON, but it looks as if we want to make this pass, we're going to have to explicitly catch the lens failure ourselves and return the right content type. But I think that's okay. We can say in here, try all that stuff. And if we catch lens failure, then we should return a response without a bad request, but with instead unsupported media type. And no body, it seems. Run that. And everything passes. Brilliant. Returning to the comparison of the two tests, I'm just going to check that we haven't cheated, that the logic in the http4k test is the same as the Ktor tests. And looking down, I think that's quite reasonable. What I am going to do, though, is to change the http4k routes so that it's simpler, removing some of the slightly dubious error handling. I'll be back in a minute. Okay then, so after a lot longer than I wanted really, I now have both apps in the same sort of structure so we compare them side by side. So here's the entry point. We both have a nice simple main. Set up the models in both cases. In Ktor, we create an embedded server. We tell it what actual server we want to use. We tell it what port. And we have this idea of a module. So this configuration block here is a configuration of our application and calls this module function here. And then we start the server and it runs. http4k is quite similar, but it starts from the perspective of roots. So roots are its fundamental idea, and given a set of roots, we can expose them as a server, in this case also as netty, also on a port, and we also have to call start. What there isn't is the idea of an application. So here we have application module, it says how we configure things. That really just doesn't exist in http4k. I'm just going to time the server startup. So I've added code to measure the time. Let's run this one. And it looks like because we wait true here, we haven't actually reached that code. Let's undo that. If I put wait false, maybe run again. Well, wait false exits. So I don't quite know how to time the startup and have it running, but the answer appears to be somewhere around 260 milliseconds. Let's try a similar thing for http4k. Okay, that has started and is running and took 170 odd milliseconds. And I've actually run those a few times and they seem quite consistent. Obviously some of that startup time is the actual server, netty in both these cases. But for this simple app, it seems that http4k is around 100 milliseconds faster to start. By the way, if we want the blocking behavior that we had here when we set wait is false, we can say .block in here, but I don't know why you would. Moving down the files then, in Ktor, we had this application that we need to configure, and we do two things. We configure the routing and the serialization. This configures serialization, installs some content negotiation and JSON, and I assume that's Kotlin serialization JSON, yes there. So to give something to compare with, I've created a JSON strategy, if you like, or context in main here for http4k and called it Kotlin serialization. But note that we're not configuring the application with it, we're just going to use it at some other point later. I think that Ktor has this application so that it can be extended, but it's a bit strange that we have a mutable thing that we then configure. So we have a base application and we add to it routing and serialization. In the case of http4k, we call functions like roots4 that return data structures, and then we act on those data structures as in creating a server. Again, it doesn't really have this idea of an application. All it really has is a single HTTP handler that we expose as a server, and that HTTP handler may itself delegate to other HTTP handlers by means of the routing. Okay, drilling down, in Ktor we configure the routing, and then again is a DSL thing where we have an application routing block that we call functions on, so we're mutating a routing table in some sort of way. In http4k, our roots4 is calling a simple function, roots, not an extension function, the routing over here. So all it's doing is creating data. And again, when we look at the return type of this, we'll see that fundamentally it is request to response or HTTP handler. So there's not really configuration going on. What there is calling a function that returns a function that knows how to do routing. In both cases, we can specify subroutes. So we've got the customer routing and some order routes here. In the http4k case, we can specify the route of the customer's routes, or the route of the order routes. We might be able to do that somewhere here in Ktor, but I don't know how to. Okay then, drilling down, customer routing in Ktor, and routes for customers in http4k. I've made these the same order, tried to make them look as similar as possible. On the left-hand side, we're an extension function on route, which means that we are adding things to a routing table. We are mutating a route by adding routes to it. http4k, on the other hand, again is just calling a function here, routes, that is returning HTTP handlers that are bound to subroutes. The fact that all these routes are under customer is expressed here as the route of the customer, but was up here in the case of http4k. I'm not sure that's significant. Within this route then, we're specifying a get handler here, and we have a block, and the block takes an implicit call. It comes from a pipeline context. So we look at that call, as in here we're getting parameters from it, and then we call respond on it when we have some data. So again, this is quite mutable. We're taking a call object and mutating it in some sort of way with our response. In http4k, we're just taking a request, you can see one here, and we're returning a response, one here. So we're never mutating the thing that comes into us in any way. We can get things from the request and we can create a response and configure it, but we don't have a call object that represents both at the same time. We also have a difference in philosophy around the body. So here we have call respond, which can take any type, and we have respond text, which takes a string. In http4k, by default, bodies are just strings, which is kind of the truth of an HTTP response. But we have extensions that allow us to treat that as JSON. And in this case here, this JSON here is bound to this example app JSON here, which is the one we created at the top. Now, I have to say that this response JSON here was only added last week. And this request JSON here, the one that we wrote 20 minutes ago, has already been adopted by the library. So the authors are still finding ways to make http4k more expressive and more convenient. In both cases, though, we have a nice DSL that expresses the structure of our routes with the structure of our code. So that's good. Finally, onto the tests. Again, I put these side by side to make them look as close as possible to each other. And I've stripped back the http4k versions to use the strict assertion library in this case. Our setup of these tests is much the same. The major difference is around the application. Because Ktor has this application, we have to create it somehow. And so we had this test application with that we built that calls this test application, which has to build an application and give us a client to it. In http4k, which is really just based around the handler, we call routes for to get a handler. And once we've had that handler, we can just use it. That said, the tests after we've got an application look very similar. We don't need a client in http4k. We can just send requests to a handler. The only perhaps significant difference is if we have to configure our request in some way. Let's see where we get a post down here. Here in adds a customer, client post again takes a block. And again, we can see that in order to get this DSL, it must be setting up some sort of post request and then mutating it, setting the content type and the body. In contrast, in http4k, we simply create a request, and then we create another request that has a body onto it, and then we have a single object that was never mutated that we pass to the handler. Whether you like this DSL style or this style here is something a matter of a taste. Although note that we can create a request anywhere and pass it around. Here it's a lot harder to create the thing that represents this because we're calling a method on post. So if we want to do something that's almost identical because one is a post and one is a patch, for example, in the case of http4k, we just have 2 lines that were identical except for post and patch. Here we'd have 2 lines that are identical except for post and patch, but they'd be harder to assign to a variable and pass around. Not impossible, just harder. And finally, one interesting thing that happened to me, if I go back up to the top, here I'm just using JUnit and assert equals using a with block to give us a parameter. The same code over here is using strict. So I tried to make this work with strict. So we should be able to say expect that client get customer. And then in here we can say get status is equal to HTTP status code OK. that's done that one. And we should also be able to say get body as text is equal to no customers found. But we have an error, and it is that suspension functions can only be called within a coroutine body. So perhaps predictably, body as text is a suspend function in Ktor, I guess because it may need to read more bytes off of the network. Whereas body string in http4k, well, it may need to read more bytes off the network, but if it does, http4k is happy to block a thread doing it. Over on the left, the suspend funness of body as text causes a problem because get in strict doesn't take a suspend fun here. Now, I don't know whether strict has coroutine support, but it's an example of where if we start using suspend functions rather than just plain data, they start causing friction in our code base. I had thought though that when I looked at Ktor, my major takeaway would be suspend functions and coroutines. In fact, though, that's not my major impression. My major impression is the pervasive use of Kotlin builder DSLs to configure the application, the routing, get requests, post requests, and so on. That leads to quite a nice syntax, but personally I think I prefer the direct data-oriented approach of http4k. Your mileage may vary though, and I may have missed some of the fundamentals of Ktor. If you think I have, then please let me know how I'm wrong in the comments below. Like this video in any case, and you could support my work by buying a copy of the book that I wrote with that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.